Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone for having our webinar, Biotechnology, Science, Business and Society. Today is the 41st webinar. And we are happy today. We have a very special guest, which is Dr. REEZAL ISHAK. He's an associate professor and currently the dean and the head of the campus of University Kuala Lumpur, Institute of Medical Science Technology, UNIKL, MESTECH, in Kajang in Selangor, Malaysia. He graduated with a Bachelor of Biomedical Science honors and holds a Master in Science in Pharmacology at University Putra, Malaysia, one of the top universities here in Malaysia, this research universities. He later received a Doctor of Philosophy in Medicine from the School of Medical Cardiff University, which is a very known university in Wales, in the UK. He teaches undergrad students in the biomedical science and medical laboratories technology programs. Through his teaching years, he has supervised many research projects involving students at undergrad and postgrad levels. In the present days and previous days, he has awarded several research grants from governmental agencies and UNIKL for almost about $500,000 ringgit in total. His research primarily focused on inflammatory study and wound healing activities with a specific interest on the role of polymorphonuclear cells. He is an expert in neutrophil cells signaling and laboratory animal study for scientific purpose. Today, I think all of us have high interest to hear you, doctor, because of the topic I want to talk with us today about how to use fish as bioresource in wound healing, which is, I think, very hot topic nowadays. And we are very happy to hear from experts like you today. Thank you again for accepting our invitation. And we are all waiting for your very interesting talk. Thank you.
Thank you very much, Prof. Ishak. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all. Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. First and foremost, I would like to thank Institute of Bioproduct Development, UTM, for inviting me to share this wonderful platform and to at least disseminate the work that my team are currently doing, and hopefully it will bring benefits to all, especially the audience. And I also welcome any perhaps potential collaboration in the future that can also enhance my study as well as perhaps your study in the same area that we're looking at. And as mentioned by Professor Hisham just now, thank you very much for the kind introduction. I believe we all have that kind of experience through our academic collaboration and so on, to have people around us to help and expand our network. So one of the, maybe this a selfish part from my side, I'm also using this platform to expand my network on the work I'm currently doing. And when I was invited to give this talk today, I tried to fit in with the, you can say, theme of this webinar, which is Science, Business and Society. And what I'm sharing today, and what I'm about to share today, is basically not an extensive data, because it's an ongoing work that myself and my team are currently doing, but it has sort of progressed into quite an interesting area where we can, after this, look into part where we do the business of it, okay, and then how we can contribute back to the society. But that's how I believe as science progresses, we should be able to, with the outcome that we do or the findings that we have, we could be able to give it back to the community, and how we can help the community to then help them to eradicate any problems or issues they are facing. Okay, and for today, my topic I'm sharing will be on the exploring the potential of collagen from the scales of OREOCHROMICS niloticus fish for wound healing. And Of course, I think everybody's familiar with collagen and fish. Yes, of course. And OREOCHROMICS NILOTICUS is what we know or also known here in Malaysia as the red Nile tilapia fish, in which you can find in any wet market here in Malaysia. But instead of looking at using the fish itself, we are looking at the scales or waste product from the fish that we can explore, and hopefully we can then look at how we can enhance the usage of it, waste product, into something which is beneficial. Okay, and before we begin even further, let me introduce. I think I'm not sure how many of the listener today familiar with University Kuala Lumpur, but looking at this picture here, this is a very, I would say, exclusive view. This is not us. This is not UNIKL or University Kuala Lumpur building. This is the view that you can enjoy when you're standing or sitting on top of UNIKL rooftop. We have our main campus or chancellery building in Jalan Sultan Ismail, Kuala Lumpur, right in the heart of KL, and you can enjoy the view here. Perhaps if you have the time, or maybe in the future you're visiting UNIKL chancellery main campus, we can also enjoy this exclusive view on the rooftop, and perhaps we can enjoy the sunset as shown in this picture. Personally, I myself have never been up there during sunset, so maybe it's a first for anybody who wants to visit the rooftop of UNIKL. Yeah. So this is the one of the campus that we have, and this basically the main campus for UNIKL. But for myself, I'm coming from, as mentioned by Professor Hisham just now, I'm coming from UNIKL Institute of Medical Science Technology, UNIKL MESTECH, in Taman Kajang, Central Kajang. So if you pass by Kajang area through Silk Highway, you should be able to see our building with very decorative color on the building here. And if you are acquainted with UNIKL previously, I'm sure that most of you know that most of our programs at UNIKL is engineering technology based, but we do have medical and health sciences programs like ourselves here in Kajang, as well as business study and IT. Okay, and my focus of our campus focuses on the health sciences, allied health sciences program, and that is where the research work is done currently for our campus. Right, and so let's go straight into what I'm about to share today. I only have about half an hour to 40 minutes, so I hope I can squeeze in everything to make sure that the message can be conveyed to all the viewers today. Okay, one of the problem that I have been looking at ever since I'm involved with research is on the inflammation and wound issues faced by patients. And one of the current occurrence, or quite common occurrence, is what we call as surgical site infection. This is considered as the second most common, what we call as hospital-acquired infection. And having this kind of infection, it may lead into another kind of wound disruption, because of course healing is required. And healing means you want the patient to heal faster and then get or gain back their mobility or the use of their normal body physiological function. So because of that, this is a matter that we need to address. And if you look at, I'm looking at the data from Malaysia, and back in 2014, it has been identified that about almost 26% of what we call as HAI is part of the problem. And because of HAI, means it happens in the hospital. And then if you look at the most recent study reported in Malaysia, you see there's an improvement in the percentage mentioned by the researchers in 2019, Wong and Holloway, which mentioned that there's only 13.8%, means the rate has gone down. And this shows a large decrease and improvement in terms of how hospital nowadays you can say control the kind of infection that happens during that time. But when you look in the further detail of the data presented, the study only examined patients who undergoes elective procedures, means not those who are with having serious problem, wound healing problem, including diabetic wound and so on. So maybe the rate 13.8% is true if it involves emergency procedures, but other procedures which involve maybe even burn wounds issues or even accidents that requires a prolonged bedridden sort of situation. So those are the kind of percentages that is not put into the study mentioned just now. Because of that means there is still a high chances that this kind of problem exists in the hospital. And the idea is that we want to produce or we want to come up with the products or any kind of substance that can help to make patient heals faster and then gain their own normal function afterwards. So that's the problem statement we're looking at, and we are studying how we want to look at least, if not 100% heal it to expedite the healing process on the patient. And because of that, so after an extensive study, research, literature review, we've discussed among ourselves, and as we start to look, our research team start to look at collagen. This is, of course, when I mentioned collagen as a novel additive, means it is well known, collagen, but the source of collagen is what we're talking about. The source means you can have collagen from the whole fish itself or collagen from any kind of animal. But my focus is more like looking at collagen from waste product that can you can say recycle it into something beneficial. And collagen in this manner, of course, maybe has a higher potential. Of course, if collagen that you take from the flesh of fish, normally people would like to eat the fish rather than make it into collagen. But the waste product is something we can process and make it into something beneficial. Of course, this waste product is not going to be used anyway. But then again, when we talk about collagen, there's a high demand of collagen usage for either medical application or even pharmaceutical application for that matter. And one of the main issues that when we talk about collagen and we look at the issues that comes with collagen that comes from land-based animals, this is something which is a concern, especially for Muslim users. Muslim users means they want to use collagen, but land-based animals, somehow or other, there's always issue of halal product and so on. And most of if you see collagen that comes from land-based animal, most of them comes from the source of pigs. And of course, this is considered as not halal or not acceptable due to the religious belief, as well as for the Hindus, as if they're using land-based animal that produce collagen from cows and so on. So this has become a concern, but the demand is there. So we are looking at how we can produce a product that acceptable by everybody, right? Without any issues of halal or not halal and so on. So we explore into marine collagen, such as the fish, the red Nile tilapia fish, and this has a very better option, I would say, because of it has quite a good bioactive compound from its nutritional perspective. And if you look at the data that comes from FAO, United Nations, data from Malaysia, this is the fish organization that look at data of fisheries usage in the whole world, in fact. But in Malaysia itself, we look at the fish waste, which is about 25% of the total annual production, and means the waste from fish is in tons almost every year, and majority of the waste is in the form of bones, skin, scales, and the fins. And when people talk about fish, they want to eat fish. If you fillet the fish, almost only 30% of the fish flesh being used for food production. 70% is being discarded as waste. And but of course, in Malaysia, if you look at how we eat fish, I don't think it's 30%. It's more than that. We have ikan bakar, we have kari kepala ikan, and so on. So that is different matter. But the fact is that there is still a lot of waste coming out from the fish production, and that is something that we are interested in, and we are looking at how to develop that into something beneficial. And and this is something which struck me from my reading, which I believe this was produced, or this was published last year by Newsweek. If you see, this is one of the study currently being done. They're still using the same red Nile tilapia fish, but the difference is that they're using the actual fish skin. So it's quite interesting way to look at it, and I'm sure that this is not the first time you've seen something like this. If you look how the fish skin is applied to the patient here, this is burn wound patient, and you can see that I'm not sure whether if you are the patient, you would enjoy something like that. It's almost like Aquaman suit you're wearing there, and this somehow rather works, but I'm not sure whether everybody everybody can accept the fact that we're using this kind of materials for any kind of wound or burn victims to use this kind of method. It is still acceptable, but one of the challenges of to produce this skin from the fish is that you need a skilled person to if you are quite familiar how to skin a fish and to skin to take the skin off the fish, you can only do this with fresh fish, and if you do this with frozen fish, you will end up with fish and chips perhaps. You're not going to get something as nice as that one. So there is a bit of challenge, but it is one of the plausible way of treating burn wounds. But what we are looking at is not using the skin itself. We're looking waste product. Okay, for as far as I'm concerned, the fish here is still edible part of it and has a lot of source of protein still. You can either eat it or you can put on any patient in this way. But we are looking at using the scale that comes out of this fish skin, and from that point, we have done extensive study. From my part alone, I've studied from the wound healing activity up to the level of inflammatory signaling and looking at infected wound and so on, until we derive at a very comfortable way of saying that looking at how we can implement collagen into something that is beneficial and focusing on not the main product of a fish, but the waste itself. So this is where the research starts. It's a lot of, I would say, downstream, upstream research, talking to the end users, talking to academicians, and during that conversation, I have also had the opportunity to expand my network of people working on collagen, and we then find a suitable way of looking at how we can implement the best way of producing collagen and applying it to patient. So the idea is to bring whatever we are doing from the lab into production, and then perhaps on the medical application. Of course, this is still a long way to go, but we have started this back in 2017, I believe, and we are looking now at the very further part of it. But I have to say that when COVID came, it does disrupt our planning a bit, and we are a bit behind time when you talk about the progression of how I would like to see the research and the findings, the outcome from this can be then translated into something different in the future. But we have a basis of understanding how the use of collagen and so on can be used to help with the healing process as well as inflammatory reaction that happens on patient, or in our case on our animal model. So understanding the whole concept of this, then we start to embark into the development. So I've been blessed with good people helping me. I have my student, this is the main man on the left there, Muhammad Adlan. Not the fish, the guy who showing you peace sign. So that is the main man that's working on the fish scale extraction to become collagen and so on. So we source out our fish from local market, and most of them, I think right now tilapia fish or tilapia fish is quite common in Malaysia, but they have their own season of when they are good enough or big enough to be harvested. So after acquiring number, I think kilos of animals or of fish, then we start to then process the scales. And what we did in the lab is we produce what we call as acid solubilized collagen. There's two ways of producing the collagen, either acid solubilized or pepsin solubilized collagen. And acid solubilized, it's not a big of issue. We use acetic acid as the main solvent. But when we talk about pepsin solubilized collagen, that is when we kind of a bit at a junction of discussing whether should we proceed or should we not proceed. Not because of it's not good, but pepsin is still, pepsin solubilized collagen is still good, except that if you look at the source of pepsin that's available in the commercial market to be used to process the collagen, it comes from pig. So it goes back to against the idea in the very beginning, because we want to make sure that the product or the collagen that we produce is clean and halal based. But when you mix it with pepsin, which is based from pig, so it kind of contradict back on what we are doing. So, but we're still exploring that. We're gonna use that in the future, but at the moment we are focusing on acid solubilized collagen and how we can apply this to wound healing on animal model. And if you look, this is another question always raised by viewers. When we look at the yield from the scales, it's quite small. I can say that I can agree that it's small. It's between 5.5 to 7% of the whole total scales that we have, and only about that much we can produce the collagen. But still, it's a good basis for us to use this waste product, because from waste we can then produce something beneficial, except that the process, I believe, can be optimized, and then we can see how this optimization can produce a higher yield. And this is one of the idea of how we can also support the sustainable development goals mentioned by UN, which is to use items responsibly, as well as enhance the welfare or health care for the citizen or for human being. So this is what we are looking at. And once we have the amount of collagen there, what we did is we did a lot of animal study for our research, and we use animal model. We use starting with mice, and now we are using rats as a big animal model. And what we did to the animals that we inflict wound, as well as, and then we inoculate bacteria onto the wound to recreate what we call as wound infection onto the animals. So once you can see the animals, the wound on the back of the dorsal area of the animals starts to become sporadic. So we start the treatment with the idea is that the collagen itself can help in two ways, which is to help the healing part of it, as well as either eliminate bacterial infection or reduce the number of bacterial infection incidences on the animals. So from that onwards, we generate all the data that we gathered so far, and started off with one of my students, I know Shafika here. She did the early part of the study on the animal model. Quite, I would say that the first preliminary study was quite interesting to see the fact that when we applied last time, when we produced the collagen from the fish scale, it gives a good platform for us to then develop a different model of collagen, I would say. Okay? From the basis of collagen, which a very raw collagen we did back then, and we see that there's a lot of, although does not show much of a difference, but it has the basis of saying that you can see that we did a 9-day study of the wound, surgical infected wound, and you can see that the collagen itself, which is row C here, produce a remarkable results, helping the healing process itself. And of course, from qualitative and quantitative data, we can see that the expansion of or the speed of what you can call as the healing process is very much comparable to those treated under negative and control group. And histologically, you can see after 9 days of treatment, the epithelial cells from the wounded animal has sort of closed properly, and you can see there's a lot of you can histologically here, if you can see it, the whole structure of skins has developed. Can see the blood vessels starts to come together, as well as all the epidermis and dermis re-establishment after 9 days. So this is quite a remarkable way of looking at the progress from the very preliminary study that we have done back then. And then expanding from this, we look at on the infected wound. So this is the start of where we start to infect the wound with Staph aureus and Pseudomonas aeruginosa. And what we did, Haslina here, another student, she carried out the work where she looked at this is the challenge that we had back then, because some of the animals, when we challenge them with the bacteria, they do not survive. Once we inflict the wound and we challenge the animals with bacteria, they can only survive for about 3-4 days, and then they died prematurely before we can even look at how the study can progress, how collagen application can help with the whole aspect of expediting wound healing and eradicating all the infection. So it was quite like an incident where we want to make sure that the infection stays there, as well as the infection can last long enough, so that any kind of challenge by substance can be, you can say that you can justify the effectiveness of it. And looking at the progress made based on wound scoring of Staph aureus infected wound and the Pseudomonas aeruginosa infected wound, the result is encouraging, looking at how the level of the wound expediting wound healing in the process from the very beginning until the end of the study. It shows that again, collagen itself has the potential to form what we call as scaffolding for the cells, especially epithelial cells, to re-epithelize, re-establish, and then form the layer of epidermis skin all over again, as well as helping the epidermis. You can see the whole structure establishing almost like a normal cell after about 9 days. So this is the way that we look at in terms of wound healing with infection. The collagen itself can help with how the cell progress, the epithelial cells progresses and close up the wounds in due time. And in addition to that, another group of students at the same time as Haslina working on this, they are also working on looking at the infection on the wound itself. So we did what we call as the colony forming unit count, cell count here, and by using a swab stick, we swab the wound on the back of the animals to see the amount of infection, CFU, of Staph aureus and Pseudomonas aeruginosa from the very beginning of the study until the end. There's a lot of bacterial study that comes together at this point, and Adlan and Nazri here is the main man that look after this. They do swabbing on the animals almost every day and do the cell calculation, the CFU calculation, and it shows that the collagen itself, whether it has a massive potential, we do not know yet as of now how the collagen kills the bacteria per se. In this case, we are doing that in a different study, but we do know that when the healing progresses and the infection exists, so what the collagen can do is that it can help expediting the wound healing process as well as reduce the number of bacteria. It does not really get rid of all the bacterial infection. It's still present on the wound, but at least it has quite a reduction as compared to the negative control here. So still, if you compare to the positive control, much of the desirable effect will be seen under the positive control when we treat the wound with acryfulvin. But at least it gives us a basis that we can also try to understand how collagen, at the same time of healing, it can also how it can reduce the colony of bacteria that exists on the wound. So that is part of the development that we are working on from the research part and the developmental part, and as well as I said, we want to understand a deeper level, this surface level, and we also want to know the deeper level on the molecular functionality of how it works and how it can help, how collagen can help with a focus sort of area that we can target as the main you can see a main target for the wound healing process to happen at molecular level. And for that, I have another student, Nabila Hanim, will be working. She's not working on this yet. We are developing still, because as I said, this is a progressive work and it's still ongoing. So what Nabila Hanim will be doing in the future, maybe if there's a point or an opportunity for collaboration, this would be a good point that I would say I would also like to find out and other expertise that can help with this kind of work. What we're trying to look at after this is understanding the functionality upregulation of matrix metalloproteinases, or MMPs, in wound healing. Particularly for wound healing, when you talk about wound healing, some of the prominent MMPs involved is MMP 1, 2, and 9. So that is the molecular part we are looking at. And at present day, MMP 9 and 2 in particular, it's almost always present when we do immunohistochemistry study on the surface of the wound itself. So this is another target, which means MMPs itself, and in contact or in when it comes into contact with the collagen itself, it can help expedite the whole process of healing based on what we can say the scaffolding. So as I said, the collagen itself, it becomes a scaffold for the cells. In this case, if you can target MMP either 9, 2, or 1 as the main molecular protein that involved in the healing process, we can then use a very minute way of looking at focusing at particular MMPs to help expedite the whole process and making the collagen more specific to target certain MMPs. So this is the current study we are looking at, progressing into this. I do not have any data for this as of now, and the grant I'm holding right now runs until 2026. Inshallah, we try our best to answer one by one all the questions we have raised, and hopefully this will give a lot of input in the next 1 or 2 years. And as we progresses, I think there's a lot of new findings that we find along the way, and that definitely give us a new perspective on how to tackle it. We are also doing like ad hoc side projects to look at how we can expand this kind of study to also make sure that we are not just focusing on like my sharing today is focusing on the scales, usage of scales to become collagen. On the side project that we have is we are also separating the bones from the fish, and that is another part of it that we are looking at. Maybe if we in the future I can get good data from both sets of materials that can support each other better, and to look at which one is better for the usage in the future. But at least we understand the principles so far and how we can then move forward and tackle the kind of issues that we are looking at this point. Okay, then coming to the commercialization process. This is something, another part of, as the webinar title goes, business society as well. This is the business part of it. The main goal at the end is to produce a product that can be commercialized. And in the lab, we have trial and error. Some of the materials, we know how to produce collagen, up to the collagen powder, and then the powder itself, precipitation itself, and how we then deal from that to become something that is applicable or you can apply to the wound, or to at least how you can tackle different kind of wound in that manner. So in the lab, what we have done, Adlan is the main man again, and what we've done is that we have produced gelatin. So these are all different forms of scales or collagen from the scales. Originally, collagen, then we make into gelatin and hydrogel and then polymer. So we are trying this. We have not implemented, or we have not applied this on the animal just yet, but we have done something. This is under undergraduate study that has just completed a few months ago. We have done something on gelatin, but that is from the bone base of the fish. But we know that gelatin itself, it has its own potential. It means the collagen made into gelatin, and that can be applied to the animals. And then we also have, what we have in the lab right now is the hydrogel that we have extracted the collagen, and then we use the precipitation of the collagen and make it into hydrogel using HPMC, hydroxypropyl methyl cellulase. And as you can see that this is more like, you can say cream-like, not cream-like, lotion-like perhaps. But to be honest, I think the outcome is not something which is I would love to see. Definitely, I would love to see sort of a clear product, translucent product at the end. But still, we are trying to find the best formula to then develop this into like a better looking hydrogel. That is one of the idea. And we also have the polymer wound dressing. This is what we will be doing in the near future. Is we produce this polymer. We have tried and error, and this is just polymer. The idea of polymer to then apply to you can cut this polymer into the shape of wound that you want to treat, for example. And looking into the example I've put in the very beginning of my talk, you see the fish skin on the hand of the patient. We can use this. Of course, if you have larger wound area, you must use a lot of this polymer to be put on the patient. But at least we have a basis of how this product can then be applied onto the wound. And all this product, the idea is that, as I said, when this wound exists, so open wound means there's a gap between the epidermis structure. So what we create here with the hydrogel or with the polymer or even with the gelatin is a scaffold on the surface of the skin, so that the skin or the epithelial cells can then regrow, and epidermis and dermis can grow just nicely, right? So that's the idea that we have, and wish us luck that we can make this product better. And at the moment, what we are doing in the coming future is we are testing hydrogel in the near future. Even I think this work will start next month. We are testing the hydrogel on the infected wound, and we will get, I think, a very extensive data. After that, we can then study and see the effectiveness of this hydrogel on the animals. Right, so then having that idea in place, that completes the whole ultimate research goal of our team, from the laboratory work to the bedside is what we are aiming for, from a mere fish that you just eat, or the waste product that you just throw away. We produce into something which is beneficial, and hopefully that we can commercialize this in the future. Of course, there's a lot of steps that you must go through before you ended up as commercial product. But I believe there is a basis of platform that we can look at, and how we can also look into enhancing whatever we have, and enhancing the idea that we have at the moment. And again, as I said in the very beginning, one of the idea, or one of the opportunity I have with IBD platform today is to broaden my collagen network, what we call it. I have the opportunity to work with a retired Professor Abdul Manan Mat Jais, who owns AB Manan Biomedical Sdn Bhd. He's a former professor at UPM, Jabatan Sains Bioperubatan. And through his contact, we have built a network of people that work together. And I believe I've been in contact with Dr. Rosnani as well from UTM. And I had the opportunity as well to visit some of the colleagues here, Prof. Mamun in Bangladesh. He has extensive knowledge on collagen, as well as the, what you can say, source for the fish, collagen and so on. And recently, I just came back from Cambodia. There's another network that I think we can leverage on. And previous a few months ago, I think in Ramadan, I had the opportunity to visit Professor Sung Ling in Taiwan, and that is part of the collagen network that I'm building. And everybody
Okay, I think we have a hiccup here. Hopefully, Dr. Rizal can recover soon. So while waiting for Dr. Rizal, I think we have a very insightful discussion. We have the very insightful discussion today. So hopefully Dr. Rizal will be with us afterwards. Hopefully the line will be recovered soon. So okay, Dr. Rizal, I think we lost a few seconds.
Yeah.
Yeah, maybe you want to continue or
Yeah,
yeah,
just I'm about to
the
wrap up.
networking. Yeah, the networking part.
Okay, let me go straight
Yeah.
to the end of my presentation. Okay, so again, here I would welcome any kind of networking that we can do on any platform. Hopefully, we can expand this and have a better research collaboration in the future, so that we can, again, as I mentioned, the theme of the IBD talk here is to contribute back to the society, inshallah. Okay. And for that, I would like to also acknowledge the FRGS grant from the Ministry of Higher Education for supporting this work, as well as the grant from STRG, or short-term research grant from UNIKL, to start off my work very back in 2017. And this has given me a good platform to gather all the good researchers as well as students, and hopefully this can contribute something which is beneficial. And I hope that my sharing today as well can give something beneficial to all the viewers and listeners.
Yeah.
Okay,
Yeah.
and okay, before I end, I just like to give a quick shout out to all viewers, listeners. We UNIKL MESTECH, we will be conducting our international conference ICMST in KL on the 19th and 20th November 2024 this year. If you're interested to join, please be interested and please join the conference. You can find out more about the conference on icmst.unikl.edu.my. And if you want to talk a lot more to build the network, the collagen network that I'm talking about, you can come to the conference and we can chat even longer there, inshallah.
Okay.
Okay, so with that, thank you very much for listening and for your attention. So I return it back to Dr. Zarani. Thank you, Dr. Zarani.
Okay, thank you everyone. Thank you to our speaker, Dr. Rizal, for such an insightful discussion about wound healing. And then, but then to start with the Q&A, and then I would like to invite audience from the any platform, media social, our Facebook, to join us. Maybe we can raise a lot of questions to Dr. Rizal. And then to start with, maybe I could maybe Dr. Rizal, can you share with us about your? Oh, we have another question from Dr. Harrison Yaakob. Assalamualaikum, doctor. Thank you for the sharing great findings. How does utilizing fish skin in wound healing treatment in terms of effectiveness compared to current treatment? Thank you. Dr. Harrison is our research fellow, and I think she's also have interest on wound healing.
All right. Thank you very much for the question, Dr. Harrison. Uh, yeah, this will be a very, you can say, a tricky question to answer because there's no right or wrong. But you're doing comparison between what is better than the other, and sticking to my goal, to at least the research team goal, is to make sure that there is a sustainability goal that we are looking at in terms of using waste product to become something beneficial. And when we talk about how effective it is still a question whether one of the main question I always been asked is whether the process of using the materials that I'm using right now, the process itself, whether it's environmental friendly or not. Of course, there's a lot of usage of acetic acid and so on, and ACL. But the fact is that that at least fulfill the goal that we are currently doing to ensure that there's sustainability goals that we are looking at. And to say whether the effectiveness of using the fish skin in particular, because I'm working with scales, I might be biased here, right? When it comes to the application, but by utilizing fish skin, it has a quick gain. And when talking about, as the example I put just now, the quick gain is that you can get the fish skin if you harvest the skin from the like pool or the river, and then you can straight away harvest the skin, clean it up, and put on the burn victim, for example. So that's a quick gain. And of course, when you talk about producing collagen from fish, and it takes a lot of time to produce and then to process, whether the process is environmental friendly or not. So it has a different way of looking at it. But when it comes to the effectiveness, I would say that there is no apple to apple comparison that we can make here. Both has its own beneficial. It's the matter of how quick do you want to solve issues with wound healing and so on. If you think you want to have a quick gain, yeah, buy a fish, skin it, and then you get it, right? Or you want to have collagen, of course you have to process the whole thing, and to then fulfill whatever target that you're trying to get at the end, right? So, but there is no right or wrong, or there's no perfect answer for this. But I believe hopefully that gives a bit of an insight on how we can apply the idea onto any kind of wound healing treatment. Yeah, thank you, Dr. Zarani.
Okay, actually I have one question, Dr. Rizal. So what is the most important self-care practices patients should follow to promote wound healing per se?
Okay, thank you very much for the question. I think the basic aspect of care for wound is to make sure that the wound is properly clean, like you do dressing every day, and to make sure that any open wound should be covered. And then when you talk about the wound healing process itself, sometimes when you have a big wound, a gap opening in that manner. So what happens is that when the gap opening, you cannot expect the cells or epithelial cells to just sort of develop quickly without any kind of scaffolding that they can hold onto. So when you have a skin, the wound clean, and you have a scaffolding for the skin, that is what we are aiming for, and that helps the the wound to close even faster. So what practice that needs to be done is definitely to make sure that the skin itself is clean, and you have to apply any kind of substance to any kind of wound for any research study, is to make sure that you create that scaffolding for the cells to then hang on and re-epithelize, re-establish as skin again. So then afterwards, what happened to the substance that you're using, it needs to be, of course, clean off and so on. So you're not gonna have if you put fish skin on your wound, it's not gonna be fish skin there forever. Right? You got to get rid of it anyway. Okay.
Yeah.
So,
Okay. Is there any question? Any question? Do we have any question? Okay. I have another question, Dr. Riza. About the key consideration when we want to choose wound healing treatment. So I know that there has a lot of people are working with the scales, with other as well. But then the key consideration when we choosing the wound healing from different types of wound, what is the key consideration that we should know?
consideration to hang on. All right, sorry, phone ringing. So key consideration to choose. What was it? Key consideration to choose.
Key consideration to choose a wound healing treatment for different types of wound.
Okay.
Which one is good? You said that just now you have an open gap, and then this is the one. So is there any preferences where which is so as a patient, what is the key consideration for me to choose? Which one is the best for me?
Okay. Well, I believe key consideration of which you say like there's product A, product B, product C.
Yeah.
you want to
In mind,
choose
what is the key
which,
consideration? Yeah.
which is the best. I believe it depends on if you have a big gap, big open wound. Of course, you need something that can make sure that your choice of treatment, something that cover up the dressing itself, can cover up the whole wound. You want to make sure that the material itself is clean and of course aseptic, so that there's no infection coming through. That's why we're doing also the study of how the collagen can eradicate or reduce the number of infection acquired during that wound healing process. So the key consideration should be always at the type of wound itself. If you're talking about diabetic wound, that is something which is even trickier, because the patient is diabetic and it takes longer time uh, for for this for the patient to then help to help and as well as reduce the number of days for healing process to happen at that time.
Okay, Dr. Rizal, we have one question from Ida Madiha. Okay, Assalamualaikum, Doctor. In commercialization stage, how to maintain the quality of the raw material source? Thank you. Have you
All
seen
right,
that?
that is a
Stage.
great question because that is one of the problem that we face at the very beginning, how to maintain the quality of the raw material source. And collagen is easily, disrupted and easily disintegrated in that manner. Uh, Whatever you want to do with the raw material at the very beginning, it should be under or in 40 degrees Celsius, or you ice it and make sure that it's always in the form of not in the room temperature until you get to the point that you have freeze dried the material. Then you have the precipitation or powder form, then you are a bit safe to put the materials anywhere. But before that, you must maintain the whole raw material from the very beginning until you process it becoming collagen powder and precipitation under or in for at least minimum 40 degrees Celsius, so that you can still get the maximum amount of collagen when you process it accordingly. Yeah, I hope that answered the question.
Okay, we have another question, Dr. Rizal. Ready? Good day, Doctor. I want to ask a question. Is there any protocol that should be followed to do this research? Is there any?
Yeah, yeah.
I have.
Of course, there is for to extract collagen itself is a long due process, and I did not put in detail of in the presentation because if I talk about protocol itself, it will take about half an hour just to talk about the protocol. If I believe what's the name of the
Shahira, Shukri.
Shahira. If Shahira wants to know more, you can always email me. You can get in touch and we can talk further about the protocol and the best way or to optimize the collagen yield at the end of your work later on. Okay.
Okay. We have another one, Dr. Rizal. Okay, I think there's a lot of question for you today. So, salam and good day, Doctor. I have a question. Is it possible to use other waste parts such as fish innards and gill for collagen production? Do you think? Have you tried these two?
Okay. Thank you, Nur Fadila, for asking the question. It's quite interesting. Is it possible? I wouldn't say anything is possible. I'll say, but it's quite an interesting idea to use the gills and innards. Whether it's clean enough to become something that you can use for somewhat beneficial, I'm not sure about that. And of course, because it's the inner part of the fish, usually we don't eat that. But uh, well, it's something you can explore. To my knowledge, this is the kind of waste. Maybe it's too far fetched to use and extract something out of it. But if it's possible to be done, you can explore it. I'm looking more at something which is more solid, like the scales, the bones, which you can grind it or you can dry it, and still you can see it. The form is still in the scale form, but it's so biological, cellular, kind of material waste, you might have a problem processing it to become collagen, especially if it's not cleaned properly. But to answer your question, is it possible? Well, you
Yeah.
can try. I would encourage you to try and then share your finding with us. We are more interested to know.
In the conference, perhaps.
Yeah, sure.
Okay, do we have any question? Okay, we have another from IBD. Salam Doctor, since the recovery of this fish scale is relatively low, how to improve it to become one of the tangible resource?
Okay. I think it's critical question. This being asked here. Of course, to get to optimize the process itself is what are we looking at to improve as in our research team. Getting a small yield is a huge problem because you're talking about 5.5 to 7% of yield, which is very small. And there is a way that we are looking at. We are referring to other people as well, especially our partners in Bangladesh. In Bangladesh, they have a huge fisheries department over there, and they have a fishery society of Bangladesh, and they have one huge area in Cox's Bazar that I visited, and they have extensive knowledge about how to process even the fish, dried fish, and all the waste product into something which is beneficial, and they can have a huge yield in that manner. I have not talked into detail about how to optimize the process with our counterpart, Professor Mamun in Bangladesh. But there is a way on how to do it. I have not studied it in further detail. Perhaps when they come for the conference in November, I can learn more from them. I believe at this point we're also learning from others on how to get it to increase the yield of the product. And once we achieve that, I think that will answer this question. At the moment, I would say that yes, I myself, I'm not personally happy with the yield we get, but there is a way that we can achieve that in the future with good collaboration with other expertise in the same area, inshallah.
Okay, thank you, Dr. Riza. Okay, I think we have more question from Siti Zulaiha Hanafi. The doctor, are there any ongoing clinical trial testing the effectiveness of tilapia scale collagen for wound healing in humans?
Effective is scale collagen being tested on clinical setting if in Malaysia, nothing that I know of, especially with there's a lot of studies in Malaysia to produce collagen, that is true, but to use the scale itself to become a wound healing or alternative wound healing treatment, we have not applied that to the extent of looking at collagen per se. There is a extensive study on Harwan, which has been done for wound healing, but that's different species altogether. And that is the same pathway we are looking at. That's why collaborating with industrial partner helps us a lot in understanding the right pathway to go, and hopefully we can in the future come to this point of doing clinical trials and achieve the same level of substance that can be used for wound healing treatment, inshallah.
Okay. Okay. Oh, we have another question from Narina Paramasivan. Good morning, Associate Prof. Dr. Rizal Ishak. Thank you so much for sharing. Are there any specific consideration or challenges related to sourcing roselle for anthocyanin extraction? Sorry, I think this is not related to this. But then probably we have another question from audience. Okay, from Suryani Shahid. Salam Doctor, thank you for the sharing. I had consumed fish collagen drink available in the market. However, I got rashes persisted on my skin. Does that mean I have allergic to this product?
All right. So I think this question should be asked to medical doctor.
Oh,
But
yeah,
anyhow,
yeah.
but
Yeah.
one thing I would like to comment on this question would say is on the consuming fish collagen drink. There's always a debate when you make collagen into a food product, either food
Beverages,
product
yeah.
or any kind of drink, because as I said in the very beginning, collagen itself is easily disintegrated. So what happens is that collagen, when it goes into your GIT system, it kind of lost its beneficial effect of it, because it will be then be eliminated as waste product from your body. There's always a debate whether it is effective for collagen to be used for food product or for drink product and so on. But we know the fact that collagen is good for pharmaceutical product, definitely, because its topical application is very good. But when it comes to consumable products, it is debatable. And to answer whether you have allergic to this, you might as well want to look at the content of the drink that you have. It might not be the fish itself, because usually if you can eat fish without any problem, fish itself, the flesh of the fish is has a lot of collagen in it. So if you have no problem eating fish, it should not have any effect on you when you drink collagen drink. Perhaps maybe other items or other content in the drinks that you should look at. Hopefully that answered the question by Suryani.
Okay. Yeah, we have, I think, and we say this is the last question. So, Muhammad Amirul, Assalamualaikum Doktor. Saya ada soalan. Until certain degree of burning, the fish scale can be used to treat this problem? Is there any yang of burning that this fish scale can be used to treat this problem? I think this is a question. Yeah.
Okay, thank you, Muhammad Amirul, for the question. As far as I'm concerned, of course, we are looking at wound healing at the level of surface area. If you're talking about burn degree up to level 4 and so on, that is deep into the epidermis and almost to the nerve area. So we are talking about the surface. Perhaps first degree and second degree burn, that is more applicable for the application of any kind of, at least the product or the development you're looking at in the form of hydrogel as well as the polymer. We are looking at maybe up to the second degree level application. The rest, to test the substance on a third degree or fourth degree level, it needs a very extensive clinical trial, because you need to have the patient that has that kind of condition first, and then you can test it. But for first and second degree burn, I would say that is applicable based on the reading that we have done and the consultation that we have made so far, right?
Yeah. I think, well, that's bring us to the end of our webinar. Okay, thank you to our speaker, okay, and to our audience for attending this webinar. I think we hope you enjoy and found it valuable. And then I would like to call upon Prof. Hisham, our director, for the closing remarks. Please, Prof. Hisham.
Yeah, I mean, the screen is not.
Okay, Prof.
Okay, now
Yep.
it's okay.
Yeah, okay.
Thank you very much, Dr. REEZAL, for this very, very interesting, futuristic research, which is, I think, inspired by many people today. And thank you very much, Dr. Zarani, for moderating this session. I'm happy that you had previous collaboration with many researchers from IBD, like BM Dr. Roznani, who will be, inshallah, a new director effective from next Sunday. Then I think then it will be very nice to come to IBD to have more collaborations with her and the big team here in IBD in the future, inshallah.
Inshallah.
With this, I would like to say thank you very much again for accepting our invitation. And I hope, inshallah, this will be start for a big collaboration in the future, inshallah. Thank you very much.
Thank you very
Most
much.
welcome, Prof.
Thank you, everyone. Yeah.